This is my amphibian that I found in our well in 2013. And can everybody see my window here and put down a timestamp?
We can see your window and hear your voice.
Okay, yeah, this is one of the things is my presentation window, but these are my notes from various notes from earlier. But as Kevin so kindly described, in some sense, the most fundamental aspect of CoSy, first and foremost, is that it is a notebook, Captain Picard's log or whatever, because particularly having just turned 78, first of all, don't forget, and thus it's a timestamp notebook. And in many ways, and this goes back way back, is its purpose is to maximize my productivity, the increase in my productivity per unit time. So it's a very, very self-centered environment, and that you can see actually that it's a rather unique in the integration of just, if I have a thought, I can go and code it. And it really has evolved from the APL workspace, which is original motivation of Ken Iverson, and APL was, as his Turing Award lecture, was labeled as a tool of thought. And so CoSy is a unique integration of computer and human understandable language. And unlike, in a couple of demonstrations and comparisons with functional language, or even the environment seeing here, the only difference, there's no going off somewhere special to program. Any line is interpreted by the computer just by tapping F6. So when you see something happen here, it's generally because I'm tapping F6. And as a Canadian APL friend of mine said, if you can think it at the APL level, the level of math or just practical every day, you want to do something. You want it so that if you can think it, it's done. If you can write it down, and one of the things is, and I think some of the demonstration of Win32 4th in a large vocabulary like humans use, it requires the vocabulary to think it. So one sort of personal note, I came to the conclusion a long time ago that one of the ultimate pursuits, intellectual pursuits today, is the creation of programming language. I could get into a lot of math, and definitely I have interests in modeling the planet, modeling planetary temperature, but beyond any particular equation or computation in math, it's how you can express algorithms efficiently, effectively, succinctly, in general. And this gets to this Apollo 11 design principle number 1: work at in a high level language. And APL and its derivatives are the highest. They've evolved from matrix algebra, and I was in grad school trying to get an inkling of how brains work, and I was sitting in on a course in electrical engineering and pattern recognition, and it was clear that I had to learn matrix multidimensional algebra. And in fact, the crowd at IBM Watson Research knew that. And so I sort of learned matrix linear algebra by learning APL. So both of them were together, and the APL knew I could bang my head against the computer until I understood it. So you have languages sort of at the chip level, which is really where more, where 4th and so forth is unique in being open down. I mean, you just had Don and Dimitri talking about in earlier talks about actually implementing this now down at the processor within an FPGA level. And that's definitely where Chuck has opened it up. It's the only language that sort of is continuous to the chip. 4th. Then at the math level, you have Ken Iverson and APL, and then Arthur Whitney has simplified that, gone in the direction of simplification and transparency to the machine in K. And these languages, this is what pulled me to do 2 decades in Manhattan, the uses for these languages, where you can express mathematics as simply, as succinctly as you can think it. Its main use ends up being in money center banks. And CoSy actually goes somewhat higher than the abstractions of APL to a lot of language, which you'll see for parsing and things like that, but is more on a human level. And one thing, coming from the APL world, where you have symbols, and then in K and in J, you're reverting back to the ASCII, limited ASCII character set, which doesn't even have logical operators. But the thing is, you have this set of symbols, and I've got a link. This will be all in my notes earlier, but look at some of Dialogue APL. They're the main APL people out of Denmark now. That just going in a direction of an awful lot of complexity, and the simple, the incredibly brilliant simplicity of just having white space as your prime delimiter goes and gives a flexibility in naming, even with the limited ASCII character set, that is just fantastic to have, compared to this thing where you have a central committee deciding on the meaning of the fundamental symbols. And in creation of CoSy, in making this, in getting from the water to the land, in a sense, one of the most fundamental things is to have dynamic objects. So a lot of the really fundamental code is following Arthur Whitney's reference counted lists structures to go, and so you'll see anytime I execute something, you'll see actually there are perhaps even thousands of lists created and destroyed. I also found along the way use because so many really critical things are recursive. Lightweight stack frame structure is very useful. APL, one of the things, because it evolved from linear algebra, the fundamental structures were they would have a number of the header would essentially be number of dimensions, then the length of each dimension, essentially rectangular arrays. Bacchus, in his Turing speech, which preceded Ken Iverson's, said you can just do it with lists of lists. And Arthur Whitney, that's the major change in K is going to just the simplicity of lists. And a matrix is just a list of equal length lists. So the header and this is, I'll execute this, I'll hit F6 on this. The header is these, well, I should have gone in, first of all, let me put in, this is one of the things where reverse Polish is actually just much more pleasant than the complexity of syntax of APL, because I can throw a comment symbol, and one of the reasons I liked Riva 4th is that it has a symmetric comment symbol. So those the header, the 3-cell header fundamentally of any CoSy list, and you can make any fourth verb that you've got into it is something where the CoSy list vocabulary applies just by having the first cell is type. And one of the most fundamental things is 0 is a list of lists, essentially a list of pointers. The specific types are things like integers, floats, characters, well, those are the most fundamental ones. The second item is the count, because everything is a list. So it's adding plurals, if you will, and it's essentially sort of a generalization of a counted string. And then something that's more internal is the reference count. So any list sort of keeps track of its own memory management. And when the reference count returns to 0, the list is freed. So actually, that's a good chunk of the extremely the enabling vocabulary in here. But beyond even the APL level, you get human level words, and see that in a moment. But one thing I also want to comment, I added this comment when Bill was talking at the beginning of the day, on having limit areas. All the indexing in CoSy is modulo. So you never have anything that goes outside of a limit or anything like that. It just wraps. And that actually simplifies what in APL is scalar extension, they call it. But it also allows negative indexing to index from the end of an object and so forth. Some of the really fundamental words, you'll note, well, actually, let me jump in here in the middle. You've got these two types of ticks, which are very important. This left tick, which unfortunately in most of these fonts is kind of small and hard to see, too hard to see, but it, as you might have seen before, simply returns the following word as a string, a name. And of course, this is such a crucial, the tick that returns I guess you want to call it CFA, the address of a word, rather than having the word, if it's a verb, execute, is just makes so many things in APL trivial, because then these words, well, let me go and put in a comment symbol here and make this, you'll see that this tick paren construction just makes a list out of any of the words in between. But you'll see that they're very, if you will, human sorts of words, like take, because you've got lists, okay, you take lists, you cut lists, which split it into pieces on a list of addresses, and then at, which again can work on, will return a list of addresses, from a list. And then again, very human level words, like the part before the first occurrence of a phrase or string, or numbers for that matter. And the part after and including the last, is another example. And this is, again, that's one of these things that makes the naming that you get from having white space delimiting is this is write to a file or read from a file. And if I take this out here, here's a use of tick. So it's handing colon question mark goes and looks up through all the scripts that are compiled. It looks up those and returns the sections. And these 4 words here are iterators, you call them, are the things that go and because the count of the word is in the header itself, it knows how long they are. So these 4 words replace almost all looping. And there's some other ones across and some other words. But one of the things is because in 4th, you don't know how many items are on. In APL, you have the advantage of infix, the verb going and separating its arguments. You have to sort of tell these verbs in 4th, whether it's got 1 or 2. So this is, do this on each of a single list monadically in APL. Do it on each pair of items in 2 correlated lists. And there the modulo indexing goes and wraps shorter index to match a longer. Do it on holding the right item constant. Do it on each of the ones on the left. And or likewise do it on each of the right. And actually that also really comes from Arthur Whitney. So in any case, this is going and looking through all of the scripts that go into loading this, and it's monadic. It's just taking this list here and going through each of those. So here is all of the definitions of all of those words and the explanations of what, like file read here, like slurp, but returns cozy strings and frees the original. Actually, to make this a little easier, this shows you what you get when you have the integration of the language that the system is written in, and you just hit F6. Here, our shell goes and makes the word. So here's actually each of those as a separate script. One of the things is now I've got all of the upper corner words have or letters have meanings. Tick, like I say, returns the thing as a string. Store and fetch, those like with W fetch and W word and there's other ones. Those are very obviously fundamental 4th notions. And count. And then actually one of the things, and this came from, I think, a group minimalist computing on Facebook, but this is swap. I find swap, which in APL would be commute. And it's far, far more complicated. It's just swap. But I find that makes simplifies things. So here again, here's the definitions of each of those. And when it gets into things that are in the underlying Riva 4th, the question mark does is it splits things on totally empty lines. And when it gets into the underlying Riva, it doesn't follow that convention.
Bob, sorry to interrupt. How much more do you have?
Down to here. I'll get through it quick. What are we? Oh, okay.
Like another 5 or 10 minutes?
Right. Yeah,
okay,
that's fine.
Deal.
Yeah. Yeah, okay. Here I'll go and come over here to CoSy, because one of the big things is now these are my notes for 4th day, but I've now reached the point where I have an alpha level, a licensed version at sort of common APL sort of thing. But the niche for 4th or for CoSy, it really is this immediate sort of super calculator, if you will. But it is also this platform for future evolution of things. And one thing I want to point out is what you have here is something where, rather than having C at all, you know, all the variations of that, which I actually never learned. I mean, I you know, split from Fortran and just never was attracted to anything other than APL until I saw 4th. So really, this is something, if you want something that brings people into using 4th, this actually is executing directly in 4th, and it is 4th. It's just that it's gone and become a practical environment for just everyday business. And I'll skip through. Yeah, and in any case, that's prerequisite. A number of supporters are grandfathered in and so forth. But one of the most important things is it's now, and I definitely am interested in anybody who's interested in doing business. CoSy needs heads other than mine. I don't even know how to go and use sockets and interface with the web. But this IUP GUI that's in here is it's got bugs of its own, but the main thing is to go and interface with the web through browsers. And I mean, I've seen Brad is you know, master of this, but to make CoSy available as an app, and that makes it so it's something that somebody can just get on. They can start, you know, the main thing that they have to, in a sense, learn to deal with is RPM. But when the HP 35 came out, I've never liked any, I mean, RPM just is, and the enhancement and the flexibility. This is just simply far more flexible. And obviously can be mapped to all the people that are doing things at the chip level far more than modern APLs. And finally, to end with, I sort of would put it this way: I've made a bridge from 4th to APL, and now it just needs commerce to be built on top of it. So that's the end. F11, everything is saved. So that's it. And definitely, I want to talk to. I'm you know, about time I do some business.
All right. I'd like to thank anybody from the APL community for joining us today. There was some interest on one of their email lists. Anybody have any questions for Bob?
Any comments? Eddie, what the hell was that?
I want to say, I used APL when I was in college, when we were doing.
Oh, I can't hear.
John, could you come over here and talk into the mic? Hang on just a second. He's making his way in this direction.
You're going to get me to stand up.
So, you don't have to stand up. You can sit down. Just sit down right there next to the mic.
Okay, I just want to say that I used APL in a class, stellar photometry, when we had to do photometric transformations, and I really found it very simple, because if you could add, scalars, you could add matrices, it didn't matter. You just had the same code, but it would know what would be coming into it so that it would say, okay, I know what you're doing. Okay, that's the thing I liked about it. The only problem was this was back 1974, and what I noticed was the only problem was if you wanted to get the actual APL character set, you had to have a Selectric typewriter with a APL Selectric ball, typeface ball on it. Yeah. But I found it very, very interesting. But I had to fall back to Fortran because that's what everybody else was using. In fact, they're still doing it in astronomy. Because I had a professor that asked me. They said, "Hey, John, what's this language C?" He said, "Boy, it is really strange." And I said, "Yeah, it takes some getting used to." He taught astrophysics, so. Go ahead.
Again, one of the things that reason why APL gets used in money center banks, I mean, that's its market. Its market tends to be global finance, because the thing is that I had it described by a guy at Morgan Stanley one time, which was heavy into APL, and a cluster of about a dozen people with Arthur Whitney actually doing an internal specific APL A+, which preceded K. And look at the kx.com website and look at Dialogue. Those are the two Dialogue is your traditional, and they've just had their conference in Portugal, and look at that, and you'll see the complexity that APL is going in the direction of complexity. Arthur's much more into simplicity. But both of the markets for both of them are big data and complex financial things. Because if you're going to have a meeting discussing some sort of an acquisition or something like that involves, the finances of a corporation, you've got the meeting tomorrow morning. You have to work at the level of you gotta the same line that applies to a single number has to apply to a million, or now a billion.
Exactly. Yeah. It was interesting. I was looking for work, and Morgan Stanley, his headhunter said, "Yeah, Morgan Stanley is looking for people that know C++." I said, "Well, all right, if you want to be object-oriented," but I said, you can run into problems with temporary objects, especially if you have a complex class with a lot of inheritance.
Proprietary, Morgan Stanley's proprietary trading group was about a dozen people that were using Arthur's A+, and essentially proprietary trading. They actually were responsible, just that dozen people, for something like $1 billion in Morgan Stanley's profits. But one of the things is I've always been interested in APL as a tool of thought. One of the reasons why I solved N cubes, minimal paths around N cubes, was to go and do something where if I didn't have the APL, I couldn't do it. And partly, of course, it was also learning the multi-dimensional space.
I agree.
Yeah. But it does. It's simply. One of the other things I'd say, there's I almost feel that the APL world and what you see here, where essentially instead of having loops, I'm just saying do this transformation on this list, on this and objects. It's the objects.
Yeah. I don't want to know the details. Just do it.
Yeah. Yeah, and if I, going and you look at these definitions, there's hardly any definition. Let me go back to these definitions here. I thought, oh, okay. Take the last. I mean, you go and you look at things, the definitions of things like cut. They've got variations. This is a mechanism where you can have something, a colon definition, and okay, it does this, and then now you have another. It's going and making a word within it. But you see these words like the part before the first.
Yeah.
That's the whole. That's the entire length of the definition right there.
So
And these two pieces, for instance, that's stack
Bob?
frames. Yeah.
We'd like you to come back next month and expand, if you would. But at this point, we're ready to unceremoniously stop the recorder, and that will.
Well, I'm ready. I'm ready to unceremoniously go to the bathroom.
Okay.
So,
good. And that concludes this meeting of the Silicon Valley Fourth Interest Group, fourth day. And remember that we're here every month usually on the fourth Saturday. December will be the third Saturday. Also, you can see our videos, replays of these meetings on our fourth channel. I'm Kevin Appert. I'm the program chairman. I am at Forther, F-O-R-T-H-E-R at Comcast.net. And you can reach me through Meetup. And thank you very much, everyone. You can use the room. It's open 24/7 to continue this discussion. But we're here gonna pull the plug now.